AI can now simulate physics, and it's changing everything, but probably not in the way you think. For years, if you wanted to know how something moves, breaks, or flows, you had to either run expensive computer simulations or test it in the real world. Both took time. Both cost money. Now, machine learning is learning the rules of the physical world so well that it can predict what happens next without running a single equation. And that's wild. So what actually changed, and why should you care? Stick around, because by the end of this, you'll see how a model trained on video clips can now predict the future better than physicists with supercomputers. Let me explain. First, let's be clear about what the old way looked like. If you're an engineer and you need to know how a bridge will hold up under wind, or how fluid flows through a pipe, or what happens when a car crashes, you run a physics simulation. That simulation is basically a computer solving thousands of equations every single frame. Newton's laws, fluid dynamics, material properties, all of it. It's accurate. It's bulletproof. It's also slow. A single crash test simulation can take hours or days, even on powerful machines. And if you want to try 100 different designs, that's 100 simulations. That's a week of computing time. So people started asking, what if we could train a neural network to just learn what physics looks like? What if instead of solving equations, we just show the AI thousands of videos of things moving, breaking, falling, splashing, and let it figure out the pattern? The idea is simple. The execution? That's where it got interesting. For a long time, this didn't work. Neural networks are great at recognizing patterns in images or text, but physics is hard. It's about understanding causality, cause and effect. It's about predicting what happens next in a way that obeys the laws of nature, not just statistical likelihood. You could train a model to predict video frames, but after a few frames, it would start hallucinating. The predictions would get blurry, unrealistic, sometimes physically impossible. It's called the compounding error problem, and it's a real wall. But in the last couple of years, researchers figured out how to break through it. The key was a different approach to the problem. Instead of training models to predict pixels, they started training them to predict the underlying physics directly. Things like velocity, forces, particle positions, energy. They also started using something called physics-informed neural networks, or PINs, which basically means you build the laws of physics directly into the training process. You tell the model, here are the rules. Learn within them. The results have been shocking. A model trained on just a few hundred video clips can now predict how liquids splash, how cloth deforms, how rigid bodies collide, with accuracy that rivals traditional simulations. And it does it orders of magnitude faster. We're talking milliseconds instead of hours. Let me give you a concrete example. In 2023, researchers at MIT and elsewhere released models that could predict fluid dynamics from video. You show the model a video of water flowing, sloshing, splashing, maybe 1,000 frames. The model learns the underlying rules of how water moves. Then you give it a new scenario, a different container, a different speed, and it predicts what happens next. And it's right. Not just close. Right. In ways that even surprise physicists, because the model is finding shortcuts and patterns that humans didn't explicitly code in. There's another huge breakthrough: generalization. Old physics simulations are locked into one scenario. You simulate a specific bridge, a specific wind speed, a specific material. If you want to change anything, you start over. But these learned models are starting to generalize. A model trained on liquids in containers of certain shapes can sometimes predict what happens in new shapes it's never seen. That's because it's actually learning the underlying physics, not just memorizing. Now, here's where it gets real. What does this actually change? First, product design gets faster. If you're making a bottle, or a pipe, or a car frame, you can now test thousands of designs in minutes instead of weeks. That's not just faster. That's a different business model. Smaller companies can now do things that only big companies with supercomputers could do before. Second, robotics gets smarter. If a robot can predict how the world will respond to its actions, how objects will fall, how liquids will splash, how cloth will fold, it can plan better, move safer, and learn faster. This is already being used in labs to help robots learn manipulation tasks. Third, and this is the one that keeps physicists up at night, simulation becomes accessible to everyone. Right now, if you want to run a fluid dynamics simulation, you need expensive software and expertise. In 5 years, you might just describe what you want to simulate, and an AI model does it. That's democratizing, but it's also disruptive. But here's the honest part. It's not magic. These models still have limits. They work best in domains they've been trained on. They can fail in edge cases. And they're not replacing physicists. They're replacing the tedious part of being a physicist, which is honestly the best outcome. What's really happening is this. AI is learning to think in physics, not just recognize patterns. It's learning cause and effect. And that's a skill that's going to ripple through engineering, medicine, climate science, robotics, and fields we haven't even thought of yet. The wild part? This is still early. The models we have now are good, but they're trained on relatively simple scenarios. As we train on more complex systems, as we combine these models with actual physics equations, as we scale up compute, they're going to get better. And then the question isn't whether AI can simulate physics. It's what we do with that power. If you want to actually understand how AI is reshaping the world, not just the hype, but the real technical shifts that matter, subscribe. I break down one of these every few days, and honestly, this stuff is too important to miss.